Those look lovely. By the way, if I find those dirty cups in my recycling without them having been rinsed, or if I find them sitting in my sink unrinsed, A, we'll never have fancy drinks in my room again, and B, I will feed them to you.
You sound like my mom.
Good. Your mom's cool. But I mean it. Like, if you ever wondered what that cup would taste like, leave it dirty in that sink and see what happens. Is that actually the first thing I'm saying in this streaming recording? Oh, great. That's great. I'm very proud of myself. But can I tell you something? I mean it. Yeah. I don't. Okay, anyway, on to this. You're free to go ask somewhere, but no, I don't have any. Okay. Yeah, if we look here, if this line were to go through here, how many ways will it intersect our parabola? Who would? Calf will. How many places? 2. Shh. You're fine. Go. Okay. Shh. Good. So we can have 2 points of intersection. Or, of course, we could have what? What else could we have? Yeah, I suppose if it went like this, mind you, is that line a function? Is a vertical line a function? No, in fact, it is the same x value. There's only one x value, but there's an infinite number of y values. Is that a function? No. So we're not going to treat that as a line because it's not a functional line. But what if the line went like this? Is that ever going to touch that parabola?
No.
No, because it's below it and the parabola is growing faster than it in both directions, right? So that would be no points of intersection. That's easy. Now, if we can't go up and down, can we get 1 point of intersection?
Yes.
How?
Yes. Watch this.
I will watch.
Something like this.
You know what? Like,
There.
the problem is, what's going to keep happening? Whoop. Right?
It's just off.
The
but
line's
you know what I
going
mean.
forever. Yeah.
You know what I mean.
No, but that won't work. That'll always find it a second place,
Wait,
right?
just have it at 0. Have it at 0. Wait, hold on. Just have it at 0.
Is that the only line that'll work? Seth very wisely points out that this line here would only touch it in one place, and that's true. Is that the only one that works? Sorry? Sure. So what we need is this kind of line, which that isn't quite perfect. Let's try again.
Let me be smart for once, man.
Now no, you were smart. That was good. If it touches in only one spot.
That's weird. I just prefer saying keep it at 0.
Well, but that's only one example. This is universal. Does anyone know what we call this kind of line? A line that touches a curve in only one spot is called a... Very good. A tangent line. And that would have 1 point of intersection. So we're going to do this mathematically today with equations, but keep in mind, when I say, here's the equation of a line, here's the equation of a parabola, find the points of intersection, you might do the math and find that there are 2 points of intersection. Okay? You might do the math and find that there are...
No.
In other words, the math just won't work, no matter how much you fight with it. You can't make it work. Or you might find that there's only 1 point of intersection. Good. So, how do we do this? Well, you should have learned this over here, but does anyone know, we don't teach Euclidean geometry like we used to. Does anyone know who Euclid is?
It's gibberish.
He wrote a book called On the Principles of Geometry. He's very old guy. Oh, he's not old, he's very dead. He's very, very dead. He died a long time ago. But Euclid wrote sort of the first, guidelines for what we consider modern geometry. And Euclid's first axiom, does anyone know what an axiom is?
Also gibberish.
Nope, not gibberish. Does anyone know what an axiom is? Sorry? An axiom is something you say that is sort of a truism. If you say something that is like always true under all circumstances, we say that's an axiom or it's axiomatic. So if you said the sky is blue, that's not an axiom because sometimes it's not, and some places it's not, right? But if you said the sky is the air above the ground, well, that'd be true, or whatever. Does that make sense? Anyway, Euclid's first axiom, rephrased because I'm not going to write it in the original language, is that two things that are equal to the same thing.
We have to write this down.
If you want to, or don't. You're big kids, so you can decide what you want to write down. Two things that are equal to the same thing are equal to one another. And this comes up in math more than you might imagine. Two things that are equal to the same thing. So in other words, if this should be obvious, but if A equals 8 and B equals 8, then what is the other statement we can say? Then A equals B. Does that make sense? Now, that is a really obvious example, but it actually becomes a useful thing. That makes things? Two things that are equal to the same thing are equal to one another. That's Euclid's first axiom. We're going to use that in mind because what we're going to say is this. At some point, and it could be more than one point, x comma y, these functions meet. You didn't see that? I didn't see that. Nobody saw me misspell that. We'll just put a period there and move on. So
I just misspelled functions, so
that's okay. I misspelled meat. So we'll move on. What are the two functions here? What kind of function is f? F is a parabola. What form is it in? Standard form, good. And what about g? What type of function is that? Linear, good. We would call it a line, good. So we'd say that's linear. It forms a line. And this is quadratic, which means it forms a parabola, good. So how do we find where they meet? Well, the trick is to know that at some point, the x and y, these functions meet. And so we could say, a step further, we could call them xi for intercept and yi for intercept. Does that make sense? I'm just naming them. Does that feel okay? Just so I can keep track. And what that means is that if we evaluate the function f at that intercept point, we will get the y value of the intercept point. Does that make sense? What if we evaluate g at that intercept point? What will we get? We will get y at the intercept point. Does that make sense? In other words, there's one point and one point only where if you put this x value into these two functions, you will get out the same y value. Anywhere else, if you put the same x value into the two functions, they're going to give you different y values because they're different functions, right? But where the functions meet, if you put the x value in both, you get out the same y value. Now, you never have to write that again, but what that means is that, therefore, at the point of intersection, what is true? At the point of intersection, if f of x equals y and g at x equals the same y, if these two things are equal to the same thing, then at the point of intersection, these two things are equal to each other. So at the point of intersection, f of x is equal to g of x. Now, do you ever have to write all that again? No. But it's the mathematical foundation for this. What we can say is that, normally speaking, for any value of x you put in, f is going to give you some y value, and g is going to give you a different y value. But at one point, or maybe 2 points, right? Because it's a parabola and a line, there's an x value you put in that they both give you the same y value. But the nice thing is, if the y values are the same as each other, well, then we can take this one step further. If Euclid's axiom tells us that f of x is equal to g of x, then we could write it that way, but then we could also say, if f of x is equal to g of x, then what is f of x? What's another way of writing that? Well, that's exactly right. F of x is x squared plus 3x minus 2. And then what is that equal to? 2x plus 4. So our steps then are going to be set the two equations equal to one another. You never have to write everything we wrote above there, but at the point of intersection, you can always say the point of intersection is the point where these two equations equal one another. Okay, I'm just going to rewrite that without the highlighting. Do you find it helpful if I highlight?
Yes, very much.
So we know where things are coming from? Yeah, I like highlighters. They help me think, but I want to make sure I'm not wasting people's time. Okay, now this is actually just a question from lesson 1.5. What do we need to set? Now we have an equation, and what do we need to set an equation, a parabola, equal to if we're going to solve it? It has to be set equal to 0. The problem is this one isn't set equal to 0. It's set equal to 2x plus 4. Okay, can we deal with that? How do we get rid of this 2x? What's the opposite of 2x? Yeah, subtracting 2x. That'll make that go away. But of course, if I do it to one side, I've got to do it
To the other.
to the other. Good, there we go. So what will the next line be? Will I put an equal sign here? Not if I don't want the ghost of Margaret Epp to haunt me tonight. My grade 10 math teacher, and 11, and 12. She's amazing. Yeah, try to pay attention to all the details of my life, Aiden. God. No, you don't need to know about the details of my personal life. That's okay. As long as you're in the math, I'm a happy boy. Where's the equal sign go? That's about the middle. That's about the middle. Actually, I guess the middle is right about there. I don't feel like that was helpful. I did what you said! I'm definitely going to die before you. Anyway, let's move on. Right, this is just math. Anyway, okay, yeah, no, the equal sign goes under here. And with with the 2x taken away, what remains on this side?
Plus 4.
Yeah, and I'm just going to write 4. You can write plus 4 if you want. What's on this side? Did we change the negative 2?
Nope.
Did we change the x squared?
Nope.
Okay, what's 3x minus 2x?
X.
Beautiful. Okay. What next?
We get rid of that 4.
Yep. Can I, if I divide by this side, what do you want to divide by? 2x?
No, aren't we supposed to divide 2x by 2 to just get x by itself?
Why would I want to do that? What do I need this thing to be equal to? I could do that, but then I'm going to have to divide this by 2, and that by 2, and that by 2, and that by 2. Which, could I do that? Sure, but why? What am I accomplishing? What do I really want to do? I'm trying to solve a parabola. And to solve a parabola, what's it have to be equal to? Got to be equal to 0. So what you're saying, Kartik, is like you could do all that. Like that would all be perfectly legitimate math. The question is, what are we trying to do here? And if what we're trying to do is make this be equal to 0, can you ever divide your way to 0? No. So if we're trying to get this to be equal to 0, what operations do I want to do? Yeah, does that make sense? Like, I just want to know, like, I'm not criticizing, like, your math is spot on. Absolutely, we could divide that by 2 to make it just x, but that's just going to make this messier, not cleaner. So it's not that your math thinking is wrong, it's just the goal is wrong. The goal in this case is to get equal to 0 because that's how we solve a quadratic. Does that make sense? Does that answer your question? Okay. Good. But again, like you're spot on. Like what you're saying mathematically, we could absolutely do. But now we've got it. It's equal to 0 and I can solve this. Oh, shoot. No, it's equal to 4. Crap. What do I do?
Get rid of the 4.
Get rid of the 4. Okay, good. It's gone.
But wait. You have to subtract 4.
Right, because that's what's going to make it go away, which means I also have to subtract 4 here. By the way, do you see when I subtract something, I don't just put it at the end. Like when I subtract the 2x, I put it over top of the thing that it's going to go from. Here that I'm subtracting the 4, I put that over the -2. The next line, we line the equal signs up. What's left on the right side now? 0. And this will be x squared still, plus x skilled, what is still? -6. Beautiful. And now, what do I want to do with this? So the first thing I'm going to say is 2, move everything to the right so it's equal to 0. Or to the right, to the left. This is new, actually. We've never done this with a line and a parabola.
Okay.
So no, this is brand new. This is brand new. So if you're finding this a little stressful or confusing, sure, it's brand new. Now what do we do with this? Now this is review because this looks like something we did yesterday. So what do we do with this now? How do we want to solve it if we can? What's the easy way that we hope works? Yeah. If we can factor, so factor the quadratic. And in this case, we need two numbers that multiply to
-6.
-6. The options would be -6 and 1, 6 and -1, 3 and -2, -3 and 2. Which one do we like?
3 and -2.
Why do we like 3 and -2?
Because 3 minus 2 equals 1.
Very good. So we needed to pick two numbers that multiplied to -6, right? And then we need to pick the pair that added to what? What number is there? 1. I don't see a number there, so the number is 1. And 3 and -2 add to 1. So what's the next line look like? Equals 0. What's over here? You know how to factor?
I'm just writing this down.
X squared plus... Oh, you want to do decomposition. We could do decomposition. Nothing wrong with that. When there's no a value, do we have to do decomposition? What's the answer going to look like? It's going to be 2 brackets, right? What's going to be the first thing in both brackets, if that's just x squared? X. And then the second thing in this case, the first one will be... You want the -2 first? Okay, and the second one? Plus 3. By the way, if you did decomposition, Sam, you're going to get there. Nothing wrong with that. Is that what you're going to do? Were you going to break that x into plus 3x minus 2x? Well, maybe isn't a very helpful answer to me, but do you understand what's happening here? Okay. And now, if it factors, each bracket will give a solution, right? And how do we get an answer from each one? I shouldn't say an answer, I should say a solution, because that's set the bracket equal to 0. Right? So we'll say this one, we'd say x minus 2 equals 0, or x plus 3 equals 0. Good. Let's solve this first one. If x plus 2 equals 0, what does x equal? If x minus 2 equals 0, what must x have been? X equals 2. Good. And if x plus 3 equals 0, what must x have been? Good. And then we can answer it. Therefore, f and x and g at x intercept at... But the thing is, it asks for the points of intersection. Have I found the points? No. Now I've found what of the points? The x values, so 2 comma something and -3 comma something. How do I find the y values? Yeah, which equation should we use? We have two of them. You can use
You already
f at
used
x
4.
or g at x.
You already did 4. This is 5.
Oh, is this 5? I'm sorry.
And I'm still right.
We can use f of x or g of x to find the y values of the points of intersection. It doesn't make a difference which one you use, but which one's going to be easier? Yeah, why is g of x easier? Yeah, we don't have to square a number. Does that make sense? No difference to me which one you use, but if my option is between take the number we just found, square it, multiply it by 3, add those together, and then subtract 2, or the other option is take the number we just found, multiply it by 2, and then add 4, which one of those is much easier? Yeah. So, first we could do g at, what's the first point of intersection we found? 2. And g of 2 would be 2 times 2 plus 4, which equals what? 2 times 2 is 4, plus 4 more is 8. Therefore, we can put that here. And then, what about g at, what's the next one? What's g at negative 3? We would do what? 2 times negative 3 plus 4. What's 2 times negative 3? Plus 4 more is negative 2.
I'm still writing the number 5.
That's okay. Take your time. I'll give you time to write that. But do those steps make sense?
Yeah.
You set the two equations equal to one another, then you get everything to the left, so it's equal to 0. Then you factor the quadratic. Then if it factors, each bracket gives a solution. Just set them equal to 0. And then finally, you're going to have to use one of the original functions to get the y values. And I guess if you want to put 6 down here, we can say, now you know the points. And if you don't know, now you know. Yeah.
So all you did was substitute the x with the x points that you found there into the equation, and that's how you found the y.
That's right.
Okay.
Yep. And again, that's what a function's for, right? The purpose of a function is to say, you give me the x value, I'll give you the y value. And why doesn't it matter which function we use? Well, because we're talking about the only points on the graph where, when we give x to both functions, they give you the same y. Does that make sense? And again, all this crap up here, do you ever have to write that again? No, you can just start here and say if f of x is equal to g of x, then that's equal to that, and you can just go. When I was in school, we had to start with a let statement. We had to say, let f of x and g of x be equal at the point of intersection. Therefore, a lot of very formal writing in math when I was in school. That's kind of gone by the wayside. But man, if I had $1 for every time I had to write, let x be the blah, 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 blah. Oh, what? No, well, is it stupid or does it really help you organize your thinking? Let x do its own thing, man.
Stop pushing X around, man. What did X do?
It's gonna do that whether or not you write that. It's going to.
What am I, X's dad? All right. So if they factor, that's nice and easy. Of course, where could this break down? What step won't always work? Can you always set two equations equal to each other? Any two equations you can't set equal to each other? You can do whatever you want. You can put the equation on the left, then put an equal sign with the equation on the right. Right? Can we all agree on that? There's nothing you could write where you couldn't do that. Can you always do some subtraction and put everything so it's on the left-hand side? Sure. Yeah, absolutely. Does everything always factor? No. So where could this break down? At factoring. But of course, if it breaks down at factoring, you're going to have some quadratic equal to 0. In which case, what can we use? Oh, everyone stand up. Everyone up.
Nope, I'm out.
No, hey, Seth, get back here. My wheelie chairs are not your car. Thank you. Of course, you don't have to stand. I can make you stand. But I wish you would. Oh, what perfect timing. Calford, would you like to be my choir director and singing the quadratic equation?
And I'm a little sick.
All right, everyone, join in. Come on now.
X is equal to
Negative b plus or minus the square root of b squared minus 4ac all over 2a. I gotta be honest, I saw several non-participators, so we're gonna do it again. No, I mean it. I'm serious, and maybe we'll just keep doing it until you participate. Anyway, there's one way to find out. Mr. Calvert?
X is
Also,
equal to
negative b plus or minus the square root of b squared minus 4ac all over 2a. That was wonderful. Grab a seat. Give yourself a hand.
1A?
That was really
3A?
good.
No.
2a. Guys, can I say, that was actually really good. You guys see, look at them.
Attempts at harmony, maybe not. But
Yeah, that was good. Who? I need to hear my high tenors. Anyone grabbing that harmony? Right. Okay. So that's gonna, spoiler alert, that's gonna come up when we do this one. Okay, so listen. It's very easy then. Let n at x be equal to p at x at the point of intersection.
Do you know at Notre Dame all the math teachers still enforce that?
Let statements?
No, like Notre Dame and like, well, like
Yeah, they still do let statements. Good, as we should.
Trying to send me the note thing for
As they should. Because, first of all, isn't that a beautiful way to start a math problem? My cursive is not very nice. I wish I had nice cursive. My mother has just the world's most beautiful cursive writing. It's just stunning. It's so beautiful. Oh, dear Lord. God, I'm going to hear that in my dreams tonight. Nightmares of...
If only I just threw up math and it just got perfect.
Okay.
10 out of 10.
You could just say let n at x equal p at x, really. That's fine. But it's useful to say at the point of intersection. So now, if n at x, what is n at x? Well, it is this function here. What kind of a function is that? What kind of a function? It's a quadratic, which means what shape are we making? A parabola. If you put the emphasis on the different syllables, you get a parabola. Orlando, right? Did you say? Okay. And what kind of a function is that? Linear. Good. So we're finding the point of intersection between a parabola and a line. So how many solutions might there be? 2. How many might there be? 1. Or how many might there be? 0. Okay, let's find out. So what do? We set them equal. And once we've set them equal just by name, saying n must be equal to p, well, 2 things that are equal to the same thing must be equal to each other. We did that there. But that means that if n at x is equal to p at x, then it means that negative 1.4x squared minus 3.2x plus 2. Yeah, you're tough.
I have a question. When you're subtracting 1 from a singular x, would that just mean there's nothing, or would that mean negative x?
Say it again, like with negative x?
Basically, 1 minus 1. Would that be 0 still? Or
1 minus 1 is 0. Yep. And 1x minus 1x is still 0. Yep.
Alright, got it. Thank you.
Yep. Yeah, something by itself is always 0. Doesn't matter what the thing was. Okay, and what's going to go on the right side of this equation? Very good. Minus 2.4x minus 3.5. And again, I do this extra step where I just kind of show these things with the colors because I find it helpful to sort of see where they came from. I am going to rewrite that just so we can work on it a little bit more clearly. Do you have to do that in your notes? Of course not, but I find it helpful in the instructional stage. Okay. So, those same steps again then. Do I need to write them? Step 1, set them equal? I don't think so. Right? Because we know that's the step. Right? What was step 2? Factor it? Can I just factor this? I gotta move it over to the other side. So what do I want to move first? And like Kartik pointed out, if I wanted to, could I divide this by negative 2.4? Like, absolutely. But my goal here is to get what on the right side? 0. So Kartik, what's the easiest thing to do here then?
Plus 2.4x.
Yeah, you're good. Why did he add instead of subtract? He's good. He's right. Why did he do that? Yeah, if you want to get rid of a negative number, you have to add. Good. Where should I write that on top of here? Yeah, on top of the negative 3.2x, right? Again, is that necessary? No, but will it help your work be clean and organized? Absolutely. What will be on the right side of this equation now? Yeah, minus 3.5 or negative 3.5. And on the right, did we change the negative 1.4x squared? No, so I'll rewrite that. But we did change negative 3.2x. What's negative 3.2 plus 2.4? Negative 0.8x. And then we have plus 2. Oh, well, that's like climbing a hill in front of that equal sign. That makes me
Hold on,
sad.
I got another question.
Yeah.
If one of your x's equals 0, like, because on this question I have, like, because I now have.
I need
x
to,
here.
Seth, I need to focus on this right now. People can't have me answering another question. Stay focused. But I will answer that for you later. What can I do now? Very good. We're going to add 3.5. Good. And on the other side, where should I write that? Over the 2, right? Okay, what's on the right side of this equation now? Very good. And on the left? Okay. Now, geez, again, it's climbing a hill. I'm saddened by my own writing. This is why I like doing lined notes, because then I have the lines to work with. It helps me. I like lines. Okay. Now, we would normally do what? We would try to factor, but does this factor nicely?
All right, everyone, take it from the top.
All right, no, we're good. All right, but it doesn't. You try to factor, but it doesn't. So what do? Do we give up? Do we quit? Are we quitters?
No.
We're not descended from fearful men. Instead, what we would say is, yeah, so A is equal to what? B is equal to almost negative 0.8. Good. And C is equal to 5.5. And now how do we solve for x? X is equal to, yeah, but what's negative b in this case? Negative of negative 0.8 will just be positive 0.8. And then plus or minus the square root of negative 0.8 squared minus 4 times negative 1.4 times 5.5 all over all over 2 times negative 1.4. Okay, and then how do I want you to do this? I want you to learn eventually just to put this in the calculator. Help me here. Let's see if we can do this. We got this, right? 0.8. Oh, what do I need to start with? Because it's a fraction. I got to start with a bracket. So 0.8, and then plus the square root, and then I need another bracket. I'm going to zoom in on this. And I'm going to change the color on this so it doesn't blend in with what's below. Okay, 0.8 plus the square root of, and then negative 0.8. And what do I have to do with that? Square it. Minus 4 times negative 1.4 times 5.5. That's the end of the square root. So how do I end it? Close the bracket. That's the end of the top fraction. So what do I need to do? Close the bracket. What operation is a division sign? No, I just said. What operation is a fraction actually doing? Division. So we divide. What do I need to make sure I do at the bottom again? All in a bracket. So 2 times, and then was it negative 1.4? And then I need to close the bracket for the bottom division, and I should get an answer, right?
Yes.
Hopefully, if I didn't screw up. negative 2.28, blah, 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 blah. All right, you should try that on your calculator. You should get the same answer. Now, we've answered the question and we're done?
No.
What's the other thing we could get? Yeah, the other possibility is that we have this negative. I'm going to shrink that down so it fits nicely. And again, on your calculators as well, the yellow ones at least, you can scroll up and just change the negative sign from plus square root to minus square root, and that gives us 1.72. That should actually be 2.2. That should be negative 2.29, or x is equal to 1.72, right? Have I answered the question?
No.
No, what do I need? The y values. And which equation is going to make that easier? Yeah, so we can say the p of negative 2.29 is equal to negative 2.4 times negative 2.29 minus 3.5. And that's going to be, I mean, we're talking the order of positive 1.5. What is it? It's not oh shit. I don't think so. Did anyone else get that? I didn't get that. That's not what I got. Okay. Was it 1.986? All right. 996. Okay. Which rounds to 2.00, right? That's easy. Okay. So therefore, the first point of intersection would be negative 2.29, comma 2.00, right?
Yeah.
Okay, and then the second one would be what? We can do p at 1.72. And what does that give us? It's going to be negative 2.4 times 1.72 minus 3.5. So that should be, I mean, that's on the order of negative 4 and a bit, minus 3.5 more. So this should be about negative 7.8 or so. 7.58. Cool. And so what's the point of intersection we get from that? (1.72, comma, negative 7.58). All right, now, if you're doing your work, how can you check that? What's the second greatest invention of the 21st century? Desmos. God, we love Desmos. Don't we? We do, right? I do. Yeah. Nice. It's amazing, right? I love it. So, what's the function f? I don't have the note in front of me. Negative 1.4x squared. 3.2x plus 2. Great. And what was g of x? Oh, what is it? What are these? Is it f and n and p? N of x and p of x. There we go. And what was p of x? Minus 3.5. Awesome. And what are the points of intersection? The first one is negative 2.28826, comma 1.99. Is that what we got? Yeah. And this one is 1.72 comma negative 7.62. Is that what we got? And should you expect to have small little rounding differences? Yeah, if you use rounded numbers, right? We could even say on here, where is n of x equal to p of x? And it will do a fun thing on the graph. Oh, there's already points there. Anyway. So there we go. So Desmos, super helpful. How could I change the number? Is there a number I could change easily on this first parabola so that they wouldn't intersect at all? Is there a way I could change the parabola so these two wouldn't intersect?
Oh, did you make that the first number the A value of constant? Right, like just barely. Yep.
Love it. See that?
That was beautiful.
That was beautiful. That was great. Well done. Is there a different number we could change to make them never intersect? That was really good. What if I have to leave this as negative 1.4? What would you change? That was good, by the way. That was excellent. What else could you change?
You can make the parabola really tiny. Or no, you can move it over. You can do plus. Oh, no, never mind. I like it.
I like the thinking, but maybe instead of 3.2, 4.2, 5, 6, 7. The problem with that number is it's odd, right? It doesn't behave nicely. But what could you do? You could move the whole thing down, maybe negative 6. That does it. Negative 5's going to, I think, be okay. Negative 4 is getting real close. And if we play with that number, could we get it so that it only intersects at one spot? Right there it intersects at 2, but just barely.
How they do their line checks for all the time.
And there you go. We managed to make it intersect only in one spot. Couldn't have been easier. But does that make sense? Okay, cool. One last example, and I'm going to send you on your way to do your homework. This one we're going to do a word problem. Though, to be clear, is the fact that this is a word problem really going to mean all that much? Not really, but that's okay. We want to get good at spotting what's going here. So the word problem is the price of a stock, A, over a 12-month period, decreased and then increased. According to the equation, A of x equals 0.75x squared minus 6x plus 20, where x equals the number of months. The price of another stock, B, increased according to the equation B of x equals 2.75x plus 1.50 over the same 12-month period. At what time in this 12-month period do both stocks have the same price? Okay. It sounds complicated, but what's really saying is we have two functions to tell us how much a price is worth. The price of a stock is, and it's asking us when are the prices the same? Well, Euclid's first axiom tells us when the prices are the same, then the functions must be the same because they're equal to the same thing. Oh no. Oh, whoa. That was fun. Yeah. So we're going to say let A of x equal what?
B at x.
B of x when the stock prices are equal. Got to be nicer than mine. Mine is embarrassing. I need to practice.
Better than what I can do.
Used to be a lot nicer. Anyway, so we'll let A of x equal B of x. And if we let A of x equal B of x, you know I love highlighters. By the way, guys, I always keep highlighters back there. Grab them whenever you want. I find highlighters to be a very helpful way to learn. What is A of x? Exactly. What's B of x? That's okay. Does everyone see that? So when we go to solve this equation, well, I'm not going to. You are. You got 8 minutes. Get it done. Oh no, I've got a question and now I've got to do it. Right out. Get to it. Sorry? You don't say. We're looking at when lines equal parabolas. So you can get. I'll get you to fill it in after.
Can I like leave both of this? Do you want me to write it down?
Yeah, absolutely. Yar.
I might enjoy that if
Yeah, Samantha. Golly. Yep.
I haven't even tried this factoring it. I find like this easier than factoring it. So can I just always just do that?
Yes.
instead? Okay.
Unless the question says you must factor.
Oh.
But if it doesn't, yeah. Yeah, no, some people much prefer just doing the quadratic equation every time.
It's like study music. Going on a quest.
Yeah. The Beatles. Beatles are good quest music, I guess. Right? I would not bother trying to factor it. Is this going to factor nicely? Probably not, right? Sorry? Oh, like too long, like a long time. Like since I was 12 or 13. 41.
It's actually my calculator has. So that's your problem.
Is there like a set way to see if an equation can factor or not? Or like
No.
so it's a gamble.
It's a gamble. It's a gamble.
I have one of those.
Yeah, sure. Sure, yeah. Sure, yes, yeah.
Or
Here's the deal. You want a candy, you come get a candy. Don't send Kardik to do your dirty work.
Only get my candy for free.
I poisoned all of them.
All right. Team, I don't want to cut you off if you have it done, but I don't want to run out of time to make sure we've checked this, okay? So what do? We've set these equal. So on this side, I would write 0.75x squared minus 6x plus 20, right? And what's that equal on this side? 2.75 x plus 1.50. Shh. What do I do next? Can I also just subtract the 1.5 while I'm at it? Yeah. Awesome. What will then be left on the right-hand side? What will this 20 now be? 18.5. What will the 6x now be? Negative 8.75, right? How's that look? Did I do it right?
Yeah.
Cool.
I was just
What should I say now? Now, in addition to being great for graphing,
Good afternoon, Eagles. On today's cafeteria menu is roasted tomato soup for $2, assorted sandwiches for $3.50, egg salad sandwiches for $2.50, subs for $6, and Caesar salad for $4. Our featured entree is Mom T. Christos with fries for $5. That's all, and have yourselves a great day, Eagles.
oh, well, thank you. Hey, can I do this? Can I go into Desmos and say what A is, what B is, and what C is? Sure. What would I put up here then? Negative B plus the square root of B squared minus 4AC all over 2A. You know what the nice thing is? If I have to find those numbers, look what Desmos can do for me. Isn't that nice? And then what do I do to get my second solution?
Minus the square root.
Minus the square root. Very good. And there we go. How's that? Did we get those same answers?
I got mine rounded, so for 8.89, I just wrote 8.9.
That's fine. That's what I'm going to write too.
The second one I wrote 2.8.
Whoa. Okay, now, what's the question? At what time is the 12-month range to the stock prices have the same price? Do we need to find the Y value in this case? Yes or no? What's the question? The question is at what time? Is time a Y value or an X value in this case? It's the X value. So the answer is, therefore, after how many months? No? After how many months? X equals 8.9 or X equals 2.8. So after 2.8 months and after 8.9 months, the stock value was the same. Now, if I wanted to know what the stock value was, what could I do with that? If I wanted to know what the stock value was, what could I do with those numbers? Yeah, good. Does that make sense? Nothing wrong with that, but did this question ask me to do that? No. So I'm actually not going to do it here because I want to demonstrate that, like, we don't always have to answer everything. Sometimes we just answer the portion of the question that we're actually being asked, and that's okay. Questions about that? Sorry? All right, there's some homework on there. I also gave you a bonus question. What was the bonus question? Little challenge.
Find the intersection of the line y equals negative 3x and the circle. I saw the word circle.
You should work on that too. That's a good question. I like it.
You do, I don't.
I need something. I'm in the way.
Yes.
Okay.
I can do this.
Adrian's such a lovey-dovey dude today. She's so wonderful today. Ah, yes, yes, yes. You can go to your locker.
I don't. Where did it go? You're so funny. You're so
Charlotte? Want to talk?
Don't say that.
Yeah. Wait, you brought Sarah's symbol.
One of these will go for you. I will try. One of those will.
You would never survive. You like my so hard. But it was good cookies. Yeah. Well, no, she ate my cookies. So I guess she liked them. Oh my God, Sam, that'd be fine. And Davin White is right. Davin Brown? Yeah. And why would you still be free?
How about you, Sam?
Did you just take off and put it on? You actually want your hair braided? Yeah, so why don't you see it? And you have no shame in carrying that around.
Joey, you're being so antagonistic right now. It's a perfect time to do things. That wasn't hard, was it? I know, I understand.
And are you a girl?
Yeah, you too.
Apparently we're all going about it. Just one. Yeah. Don't think. Is Rhea not okay? No, she's sick. She walked to school and decided no.
You guys going to council?
Adios.
They're not? Are you not doing council, Charlie?
I like to do the activity stuff.
Charlie, don't you want to be a teacher? Don't you think it was on student council would be a big supplemental for the Con Ed application? You don't. Because can I tell you? It is. Like it is. You really should join student council. Nothing says hire me as a teacher like I don't like getting involved in school. Like it also says you're playing about Con Ed. You guys would need to make kids think about that application. What else? What you gonna do? But yeah, it's in this pile somewhere.
And Mr. Lobster after him for today's lesson, he's like, yeah, it's easy, I'll teach you. I was like,
Sorry, what was he like?
he's like, yeah, it's easy, I'll teach you.
Well, you fill it out yourself first. It is easy. It's very straightforward.
No, yeah, I'm gonna film myself at home and try and learn it first.
I think you'll be fine.
Yeah. I love this lab.
I know it's a fun one, eh?
Yeah.
I'm trying to do it from area stuff. You know, long time since I haven't had co-op students do all my lab work for me. What is this? What am I set lab myself? Stone Age?
Oh my god.
sure all the boys are on one side.
Absolutely not. Yeah, you have to. Oh, it's so
So is this
cool.
an air gun too? This one?
Oh, so where's the air gun? I had to fix it up.
I'm switching between them and more. There's a short
Mine's C24, H42, O21. You're canceled. Canceled.
Yeah.
Oh shit, that's huge.
Okay, I'll
Let's
leave
go,
you.
Samantha. Let's go, Catherine.
I don't think I'm finding anything for it.
I know.
C21, mine is actually hard.
Everybody felt like really tiny ones. What the fuck? Because I was looking at colors, and I was like, there's no way I'm gonna be able to do this unless I'm like using blue.
No. It's because like they just ones that.
I didn't even know
Like,
where
I
to
just
look up.
got a lot of information.
I didn't know where to look up these things. I just looked up fucking random shit, and I was like, that looks like something. And I looked at the most biological, and I was like, okay.
I didn't know that. Is she still doing it?
I don't know.
I don't know if she's still. I think she talked to this girl out. I don't know if it's good. But like that's maybe she doesn't decide. That's not.
It's the like right?
I don't know. But yeah, too. Your body is not producing that well. And then using that school.
What's your average?
90. I don't know.
What do you
Yearly average you add them all together.
I believe it's like probably 99.
I feel like it's probably not 90.
What's the lowest grade you ever got?
High school.
Yeah.
13 or something like that. I mean final grade. I'm gonna guess 96.
Fair.
Jesus Christ. I think I got an 80 in that class.
The highest I got was like 60. For any class.
Oh, I wasn't in the grade 10 French. Oh, I had to. For one, like 2 hours.
Did you get a Facebook?
I had to delete it because it was making me so mad.
Yeah, it makes you like only pay. It makes you like only able to order when you pay like $20.
Yes, I know. And then I was like, no. And then it was like 18 million top of that. It's too much.
It's brain rot. You're brain rot, bro. You are now.
No, I thought I would survive without hearing those words. So now that that's here, hear every
I know. How do you think I feel? He gives to Brody, and Brody spews out all these fucking words too. I'll be sitting there, and Brody will just go stupid toilet. I'm like, are you kidding?
Brody.
Rachel's Period 3 class will